Welcome to second grade Unit 6, Geometry and Patterns. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 6. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 6. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. As you have seen, some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in Unit 6 are paced in detail. This unit has 3 AKS, AKS 7, 4, and 2. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. Unit 6 is the first time this year that we will work on AKS 7. In this video, I will discuss some nuances and changes for this year. In Units 2 and 4, we explored numerical patterns through IOA 4B, but we will dig a little deeper in this unit through IOAs 4A and 4C. AKS 2 IOA 2A is an ongoing standard and will be seen again in Unit 6. You will also see that we have provided you with the state coding at the end of the IOAs so that if you're looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. IOAs without the state coding at the end are specific to Gwinnett. So in Unit 6, we have the opportunity to explore two-dimensional and three-dimensional shapes and partitioning and describing equal-sized parts like last year. Although this AKS is not new, there are some additional components to it this year. For example, IOA 7B Symmetry is a new standard for second grade. Students will identify at least one line of symmetry in everyday objects to describe each object as a whole. They will use mirrors or geomirrors, geoboards, and paper folding in order to create lines of symmetry and mirror images. Students should experience examples of these shapes within real-world context. The work students do with this standard in second grade will serve as the foundation for the work they will do in relation to symmetry and quadrilaterals in third grade. IOA 7A requires students to describe, compare, and sort 2 and 3D shapes given a set of attributes such as the number of vertices, angles, edges, sides, and faces. In addition, one consideration of this standard allows students to draw shapes as a part of their learning progression. They will describe shapes and justify their identifications based on their conceptual understanding of the given attributes. One nuance to 7A, IOA 7A this year is that rectangular prisms and cones should be added to the collection of 3D shapes for students to explore. Students should be familiar with cubes from first grade, so one way to introduce the rectangular prism is to make a connection between it and a cube. You will also notice on the instructional calendar that 7C and 7D are together because last year they were one AKS, but with the new standards, we will dig deeper into these concepts under 2 separate IOAs. Through IOA 7C, students will pick up from where they left off last year with partitioning. In Unit 6, students will partition shapes into 2, 3, or 4 equal shares. They will use the vocabulary of halves, thirds, and fourths to describe the equal shares created while exploring with manipulatives such as fraction squares, fraction circles, and paper folding. By the end of the unit, students will be able to reason about the shapes of partition sections and justify their thinking about equal-sized parts using fractional vocabulary such as 2/2, 3/3, and 4/4 to describe a whole. Through IOA 7D, students will recognize that equal shares of identical wholes may be different shapes within the same whole. Manipulatives, such as fraction squares, will be particularly important to getting this understanding across to students. In Units 2 and 4, students identified, described, extended, and created numerical patterns resulting from repeating an operation, such as addition and subtraction. We will continue this work with IOA 4B during Unit 6. In addition, we will dig into repeating, growing, and shrinking patterns through IOA 4A and IOA 4C. Remember that patterns are a new standard for second grade, and this work is interwoven throughout our curriculum, both implicitly and explicitly. It will set the foundation for students as they begin to learn about patterns found in multiplication in third grade. Lastly, I want you to remember that IOA 2A is an ongoing fluency standard and will be found in every unit. Although not explicitly stated, we have included some resources to help support adding and subtracting within 20 using a variety of strategies. Welcome to Chapter 2, Unit 6. Our pacing is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at Econ to find the pacing for Unit 6. In the box which names the unit, Exploring Geometry and Patterns, you will see the suggested pacing. For Unit 6, we suggest 5 weeks. The big ideas in this unit are geometric and spatial reasoning, patterning and algebraic reasoning, and numerical reasoning. The pacing guide is set up with a list of the AKS and IOAs, which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs. This includes the concrete, representational, abstract progression, and the progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this column. In the right column, we provide resources to guide instruction such as GCPS traditional lessons, task-based lessons, and/or resources from the Georgia DOE. Looking at the pacing, you will notice that we began this unit with 5 days of AKS 7A. Notice that it begins with 3 days of students exploring both 2D and 3D shapes on the concrete level. It is important for students to have access to concrete manipulatives while gaining a deeper understanding of the attributes associated with describing, sorting, comparing, and drawing both 2D and 3-dimensional shapes. Please remember to pay close attention to the way we have paced the bullets in the left column because we have been strategic about how we've progressed the skills within each IOA. These bullets will also assist you when you are creating lessons for the students in your classroom. Notice in particular that students should experience this IOA with examples that include real-world images. After the first 3 concrete days of 7A, we have paced 2 days in the representational to abstract phases of the CRA progression. Students will engage in a task-based learning plan and a 3-act task, both provided by the Georgia DOE. Students have already spent some time describing, comparing, and sorting 2D and 3D shapes. So the main focus of these 2 days should be on students reasoning about 2D and 3D shapes. After learning about the attributes of 2D and 3D shapes, students will begin to apply some of that learning and that background knowledge as they partition circles and rectangles into equal shares through IOA 7C and 7D. This learning will provide students with a firm foundation for fractions and division in 3rd grade. Notice that students will be partitioning into halves, thirds, and fourths. The pacing provides 8 days of practice, including the use of fraction squares and circles, as well as paper folding. It is very important that students are introduced to partitioning into equal groups on the concrete level so that they have conceptual understanding and they will better be prepared for the work that they will be doing later on with fractions. Not only will partitioning help prime students for what they will do in 3rd grade, it will also get them ready for IOA 7B. Students will identify lines of symmetry in everyday items through IOA 7B. This should be a fun standard for students to explore mirror images and congruent shapes using tools such as geoboards and geomirrors. You notice we're going to move on to the next portion of our pacing guide, where you see AKS 4 and AKS 2. As stated in previous videos, AKS 4 patterns is new to 2nd grade this year. In units 2 and 4, students identified, described, extended, and created numerical patterns resulting from repeating an operation, such as addition and subtraction. In Unit 6, students will identify, describe, and extend repeating patterns, growing patterns, and shrinking patterns. You will notice that the pacing begins this part of the quarter with IOA 4A. One of the new ideas in this standard is identifying the core of the pattern. The core of a pattern is where a pattern begins, so it is crucial that students can identify core patterns in order to determine whether a given pattern is repeating, growing, or shrinking. Students will use manipulatives such as pattern blocks and colored tiles while working with patterns. Please note that IOA 4C requires students to identify, describe, extend, and create numerical patterns within 20. Welcome to Chapter 3, Unit 6, Instructional Strategies. In this video, we will explore math instructional strategies for your 2nd graders. I would like to highlight a couple of examples and instructional strategies for you today. The first example I would like to look at is based on AKS 7, IOA 7B. 7B says, identify at least one line of symmetry in everyday objects to describe each object as a whole. There are two important things to look for when determining if an image or an object has symmetry. An object is symmetrical when one half is a mirror image of the other half. One side will look exactly like the other side. When determining if an object has a line of symmetry, you must look for two congruent parts, same size, same shape. Students are required to identify at least one line of symmetry. Although they may accurately identify more than one line of symmetry in some shapes or everyday objects. There are several ways to approach this IOA. In the suggested pacing, we have paced partitioning of squares and circles prior to IOA 7B. Because of the experience students have had with concrete manipulatives and paper folding to determine halves of squares and circles, they should transfer that understanding to the concept of identifying lines of symmetry, because identifying symmetry requires students to mentally find the line that divides an object into two congruent parts. Let's start with the concrete level. Let's look at the back of a geoboard. The shape of this geoboard is clearly a square. I know that all sides and angles are equal in a square. So I think it will be easy to find a line of symmetry in this shape. But I can't fold it, right? But I can imagine if I were to pull side B over to touch side A to partition it into two equal parts, creating a line of symmetry. I can even imagine if I move my sticky notes a little and I decide that this will be my A and this is my B. I can even imagine pulling over vertex B over to touch vertex A, and then therefore creating a line of symmetry, which would mean that I've partitioned my square into two congruent parts, and a line of symmetry would have been created. Remember, students in second grade are required to identify at least one line of symmetry, but accept as many as they find. Also notice that you will have an opportunity to reinforce geometry vocabulary that has been previously introduced in IOA 7A, 7C, and 7D. Now, you might be wondering, why am I using the back of a geoboard? Well, let's look a little closer at the front of the geoboard, or the side that we usually look in, or sorry, the part that we usually use. Notice on this part of the geoboard, can you still say that the geoboard is showing symmetry? Well, no, because the letters and the numbers, notice that there are letters on here and there are numbers. They do not create a mirror image when partitioned into equal parts. So that's sort of the tricky part of this standard, in my opinion, because while we can focus on symmetry of a square like we did on the back of our geoboard, we also need to make sure that a mirror image is created by the line or lines of symmetry. With that being said, I think geoboards are great, and they can be used by your students to create figures that contain lines of symmetry. So we are still using our geoboard to create lines of symmetry. Just be careful that we also think about the part of the IOA that says we have to create mirror images, because this is a great way with that geoboard to demonstrate symmetry in a concrete way. In this situation, students will be focusing on the shapes created by the rubber bands, not so much the board itself. Okay, so let's look at another example of symmetry using this playing card. Okay, I can imagine that a student would look at the playing card and say, absolutely, there's symmetry. Look at the hearts. This one is the same as the other one. If we folded it in half, they would be the same. Even these are upside down, if you think about this as upside down. But look what's going on over here. If I were to fold this side onto the other side, I would not have symmetry. So there would not be a line of symmetry on this playing card. So that's another really cool and fun way to talk about symmetry with your students. Okay, so this is called a geomirror or sometimes a mirror. You may also see that name for it. And we're going to be using this to show a mirror image. I'm going to use some pictures of popular logos that students may see in their communities. So I'm going to begin with this symbol, which I'm sure most of you are familiar with, the famous golden arches of McDonald's. Look at this image. I can see that there is symmetry, or it has a line of symmetry. But to demonstrate this to your students, try this task. I think it's always fun. I'm going to attempt it with the document camera. So I'm just going to show one arch like that. And then I'm going to put my mirror or my geomirror in right on that line. And I'm going to attempt to switch my camera so you can see. Hopefully you can see that the other side now has a golden arch to create a whole image of the golden arches. That shows me that this image of the McDonald's famous golden arches has a line of symmetry. There's a vertical line of symmetry there. Okay, so here we said that there was a vertical line of symmetry. You may also have a student who might say, oh, well, I can take and put the mirror right here, and I'm going to see if I can show you something. Look what happens. There's another arch that appears on the other side. But remember, we were trying to find symmetry in the original picture, right? So although it duplicated the image that's on the screen right now, it doesn't create the golden arches. So therefore, that is not a line of symmetry in the McDonald's logo. So we do not have a horizontal from left to right. We do not have a horizontal line of symmetry. We only have a vertical line of symmetry in our McDonald's logo. Okay. Okay, so let's start with Adidas. We're going to do another example, this time with the Adidas logo. I'm sure many of your students are familiar with this logo. There's the original image. I want to do the same thing I did before by showing this one and seeing if we can create, or we can create that line of symmetry, or see if there is a line of symmetry, I should say. So I put it there. Notice where I'm placing it. And then I want to kind of like scoot down. I'll move the original. Scoot down and look through to see if that image is created. Wow, look at that, right? So, using the Adidas image, is there a line of symmetry? Where? So, is the mirror image created this time? Well, when I look through the mirror or through the geomirror, I think that students will be able to see that while the shape above the words contains a vertical line of symmetry, right? Like I feel like it looks like a leaf. I'm not sure what it's supposed to be, but that part of it, it looks like there's a vertical line of symmetry. because that part is duplicated on the other side. However, the words underneath do not create a line of symmetry. It's not a mirror image on the other side. Okay, now let's look at a sample for IOA 7B. Millie was on a road trip with parents and noticed a Domino's pizza restaurant. She remembered her teacher saying that symmetry can be found in everyday objects and in the world around us. So Millie wondered which parts of the domino sign contain symmetry. So let's determine which parts of the domino sign are symmetrical. Okay, so looking at this problem, I can see that the domino sign has several different elements. I need to determine if there are any parts that show symmetry. Okay, so I know symmetry is going to show two congruent parts or halves, and it's also going to show a mirror image on the other side. So first I want to look at just a square that has the actual domino on it. So I cut out a picture or a part of it, cut this part out. Okay, I wanted to be able to look at this first. So looking at the shape of the sign, just like the back of my geo board, I noticed that the shape is square. So I feel like the shape is actually symmetrical because I could divide it and make a line of symmetry with two equal parts, vertically and diagonally and horizontally, right? But what I also notice is that there's one pip on this side of the domino and there's two pips on this side of the domino. And also the letters down at the bottom of the domino pizza sign would not create a mirror image if I divided it into equal parts, either vertically, horizontally, or diagonal. So I don't see that there's a line of symmetry if I'm including, which I should be, including the words and pictures on the shape. So let's go to the actual sign. So I actually also cut out Domino's pizza sign. I think your students would really enjoy doing an activity similar to this, just trying to investigate and see if they can find symmetry. So we know the words as a whole are not going to be symmetrical because we just talked about that with the smaller image. But I wonder if there are any letters, individual letters, that may create or have lines of symmetry. So let's see. When I look at the letter D, if I were to fold this side onto this side, I feel like there would be a horizontal line of symmetry. I could even use my mirror in the middle to see if a line of symmetry is created between the two halves. Sort of hard to show on the document camera, but in person, you could even have letters that are cut out and you could have the students fold them to see if there is a line of symmetry, if there are equal parts, and if both sides look just alike. So I noticed again that there is a line of symmetry that is horizontal. Okay, now let's go on to the O. The O, I feel like I could also make maybe two lines of symmetry. If I were dividing the O, I could make a vertical line of symmetry. There's also a horizontal line of symmetry. Again, this would be an opportunity, depending on your students, depending on where you are in your unit. You may want to have a few letters cut out. Students could fold or write on the letters to find symmetry. Now, with this M, I almost said there was a line of symmetry in the center, right? A vertical line. But then I noticed this M has a interesting little side right here that is not the same as the other side. So I do not see a mirror image that would be created from the or on the M. So I do not see a line of symmetry on the M. The I, there's a vertical line of symmetry. Again, if I were to fold that I vertically, I could create a line of symmetry. The N is that font, that domino font. I think I actually looked it up. I forgot the name of it, but I did actually look it up. I think it was called the, I don't know, you guys can Google it. But it's a font that Domino's uses. It has that little edge to it right here, and it sort of throws off the other side. So now I don't even have a line of symmetry on my end, but that's okay. We're going to go on to the O. The O we already did. All right, we see the apostrophe here. I don't know that I traced it accurately, but I do not see a line of symmetry. Okay. The S, if I were to fold the top to the bottom, it would not have a horizontal or vertical line of symmetry. The P, I don't see any lines of symmetry. We already talked about the I having a vertical line of symmetry. Our Z's are similar to our S's, or our S, no line of symmetry. And then our A is not going to have a vertical line of symmetry, but it looks like there is a horizontal line of symmetry in the A. So again, when you're working with students, make sure, and if you decide to print these off, make sure that you check before you do this with students, because you want to make sure that the font that you've chosen that you can see the lines of symmetry in them, because different fonts, print out in different ways. That's the reason why I mentioned the font with the domino letters. I can see vertical lines of symmetry on the O and the I, the O's and the I's. If I folded one side onto the other, the sides would be identical. These results can vary depending on the chosen font. I can also notice that on the D, on the O, and on the A, if I folded these letters from top to bottom, they would have the same image or mirror image on each side of the line of symmetry. These have horizontal lines of symmetry. So the O was the only one that we found that had both horizontal and vertical lines of symmetry. So I can see that some of the elements of this domino sign are symmetrical. I know I can determine symmetry when a mirror image is created and when both halves have the same size and the same shape. I use images for this demonstration, but as I said before, you could certainly use cutout letters and have students fold or draw lines on the letters to determine symmetry. Now, let's take a look at AKS 4, IOA 4A, and 4C. These IOAs are not clustered together on the pacing, but I will talk about them together in this part of the video. IOA 4A is identify, describe, extend, and create repeating patterns. Okay, so this is the one we're going to be looking at, A. IOA 4C is identify, describe, extend, and create growing and shrinking patterns involving addition and subtraction up to 20. So this is IOA 4C. Through IOA 4B, in units 2 and 4, we explored repeating patterns within 1,000, but we did not explicitly point out the core of the pattern like we do in IOA 4A. So we'll be talking about that today. So let's look at the ATS for IOA 4A. Okay, so we're going to actually go to an example in the ATS. It starts here. So it tells us that Kale created a pattern using snap cubes. Describe his pattern and determine the next two terms. So I'm going to go in the ATS to that example. So here's Kale's pattern, okay? Notice in this example that the first term shows 6 cubes, okay? And it's actually labeled right here. Then there are 5 cubes. Then there are 4 cubes. Following those 3 terms of cubes are 6 cubes, 5 cubes, and 4 cubes again. This is an example of a repeating pattern. The simplest part of the pattern that repeats is identified as the core of the pattern. In this example, there are 3 elements in the core. So this part of the pattern, this is the core. Okay, so 6, 5, 4. Repeating patterns are not new to second graders. They began this work in kindergarten. So in second grade, students dig deeper by exploring numerical patterns. Even though you may see manipulatives or pictures, please note that students are identifying, describing, extending, and creating numerical patterns in second grade, not picture patterns. Okay, let's peek at a lesson from Unit 6 of the suggested pacing. Paisley was playing with pattern blocks and created this arrangement. Identify and describe the core pattern using numbers. Extend the pattern to show the next 2 terms of the core pattern. Then create your own example that follows the same pattern as Paisley's. Well, in this example, we can see that there is a series of pattern blocks. I know we're looking for a numerical pattern. So in this particular example, we will look at the number of sides as a way to describe the pattern. I can see a square, which has 4 sides. I can see next is a triangle, which has 3 sides. A hexagon, which has 6 sides. And a trapezoid, which students don't need to identify as such, has 4 sides. So then following that is another square, which begins the pattern all over again. I can see in this arrangement that the elements that repeat are a square, a triangle, a hexagon, and a trapezoid. If I describe the pattern using the number of sides, these elements create a numerical pattern of 4, 3, 6, and 4. Therefore, 4, 3, 6, 4 makes up the core pattern. Okay, so this is my core. If I want to label the picture, I would circle it. This is the core. Okay. In the suggested lesson, students will identify the core, extend it by saying what comes next, and then create another example using the same core pattern. Notice that in the suggested lesson, the core pattern is circled. Vanderwall says, to help students, especially those receiving special education services, track the core of the pattern, highlight the core by drawing a circle around the shapes that form the core, repeating the circle each time the core is repeated. So you will see this in this particular lesson to help students track the core. Now that we have discussed identifying the core, let's talk about creating a new example based on the core pattern. This is the example given in the sample or suggested lesson on the pacing. It shows the core of the pattern, 4, 3, 6, 4. I created a different arrangement of the pattern blocks using the core pattern. So I'm still describing my pattern using the number of sides. I just have different pattern blocks. So again, my core pattern still shows 4 sides, 3 sides, 6 sides, and 4 sides again. So in summary, IOA 4A is related to IOA 4B because it requires students to identify, describe, extend, and create numerical patterns that repeat. However, we also focus on identifying the core of the pattern with IOA 4A. IOA 4B requires students to repeat an operation such as addition or subtraction. They experienced that IOA in previous units 2 and 4. The other part of AKS 4 that is new for Unit 6 is IOA 4C. In this IOA, students will identify, describe, extend, and create growing and shrinking patterns involving addition and subtraction within 20. According to Vanderwall, when working with growing and shrinking patterns, have students look for generalizations after finding the core of the pattern. 2 questions that will assist in supporting students' understanding of patterns are, what is staying the same? What is changing? He also says that when introducing growing and shrinking patterns, one should start out with fairly straightforward patterns using visuals, such as those made with tiles, counters, cubes, and pattern blocks. Using these concrete manipulatives makes it easier for students to see the patterns because they can manipulate the elements. Just like with repeating patterns, one way to scaffold for students is to circle or color code the part that is the same in adjacent terms to help identify what is changing. Now, let's look briefly at part of a lesson from the suggested pacing. Diane showed her students the following display of dragonflies. Identify and describe the numerical pattern as growing or shrinking. Extend the pattern 2 more terms and then create a drawing to mimic the pattern with a different example. So notice that students will have to identify the type of pattern. Is it growing or is it shrinking? Then they would extend the pattern. And in this particular lesson, they would create the next elements with a drawing, okay? So you'll notice that in this particular lesson, the core pattern is circled as well as I identified the change. When you work with students, be sure to identify the core pattern and have them identify the core pattern and also discuss what is different. Make sure to discuss whether the pattern is growing or if it is shrinking. Here is an example from the lesson, as I said, that clearly shows what is happening in the problem. This was our core pattern, which was the first term. There's a blue dragonfly and then a brown one. And then we notice what happens is that 2 brown ones are added And then for term 3, 2 more brown ones were added. So the growing pattern adds 2. In summary, IOA 4C requires students to identify, describe, extend, and create growing patterns within 20. Note that there will not be more than 20 elements within any of our growing or shrinking patterns in 2nd grade.
So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview. To ensure completion credit in PD&E, please be sure to complete the following Google form. Please scan the QR code in order to get the Google form. Thanks for watching.